Welcome to our deep dive into the fascinating concept of infinity. From mathematics to philosophy and physics to popular culture, infinity challenges our understanding of the universe and reality. Prepare to have your mind boggled as we explore the profound implications of something that is boundless, endless, and larger than anything we can imagine. We'll journey through the history of this perplexing concept, from ancient Greek paradoxes to cutting-edge theories in modern physics. Get ready to expand your cosmic perspective because we're about to embark on a quest to grasp the infinite. Mathematics, my friends, is where infinity finds its most comfortable residence. Think about the counting numbers, 1, 2, 3, and so on. Seems simple, right? But that and so on is where infinity sets up shop. The set of all counting numbers is infinite, meaning there's no largest number. Then there's calculus, where we grapple with infinitely small quantities. These infinitesimal values are key to understanding rates of change. And we can't forget set theory, dealing with collections of objects. Set theory allows us to compare different sizes of infinity. Some infinities are bigger than others. The set of all real numbers is larger than the set of counting numbers. Georg Cantor revealed a hierarchy of infinities. His work still boggles the minds of mathematicians and philosophers. Infinity isn't just an abstract concept, it's fundamental in our understanding of mathematics and the world. From the moment humans started contemplating the universe, we've bumped up against the mind-bending concept of infinity. The ancient Greeks, those early explorers of thought, wrestled with paradoxes that highlighted the counterintuitive nature of the infinite. Take Zeno's paradoxes, for instance. He proposed that to cover any distance, you must first cover half that distance, then half of the remaining distance, and so on, infinitely. This division into ever smaller segments seems to suggest you'd never actually reach your destination. Of course, we know in our everyday experience that we can walk from point A to point B, but Zeno's paradox forces us to confront the strange relationship between infinity and reality. Then there's the question of an infinite universe. Is space truly boundless? If we hopped on a spaceship and traveled in a straight line, would we ever encounter an edge, a cosmic wall? Or would we just keep going, forever encountering new galaxies and wonders? And what about time? Did it have a beginning, or has it always been stretching back into an infinite past? These are the profound questions that philosophers have grappled with for centuries, questions that continue to stir debate and inspire awe. The concept of infinity challenges our very notion of limits and boundaries, pushing us to consider the possibility of something without end, without beginning, a concept that seems to defy our finite, earthbound experience. Let's turn our attention to the realm where reality gets stretched to its limits, physics and cosmology. Here, infinity appears in extreme environments where the laws of physics seem to break down. Consider black holes, born from the death of massive stars. Their gravitational pull warps space-time, creating a singularity. At the singularity, density and gravity become infinite, a point of infinite density, a cosmic abyss from which nothing can escape. Black holes remind us that our understanding of the universe is incomplete. Then there's the question of the universe's size. Is it infinite, stretching out forever, or finite, like an expanding balloon? Cosmologists debate these possibilities, analyzing the cosmic microwave background radiation for clues. The answer may hold the key to understanding the universe's ultimate fate. You know it when you see it, the sideways 8, the lemniscate, the symbol that represents boundless potential and endless possibility. That's right, we're talking about the infinity symbol, a mathematical and philosophical icon that has captivated minds for centuries. First introduced in the 17th century by mathematician John Wallis, the infinity symbol, denoted by Is, wasn't just a fancy way to represent a big idea. It was a tool, a shorthand for expressing the concept of something without limit, something that extends beyond our ability to measure or comprehend. Think about it, the symbol itself, with its continuous loop, embodies the very essence of infinity. It has no beginning and no end, just like the concept it represents. But the infinity symbol is more than just a mathematical tool. It has transcended its academic origins to become a powerful symbol in art, literature, spirituality, and popular culture. We see it everywhere, from tattoos and jewelry to logos and artwork, representing concepts like eternal love, limitless potential, and the pursuit of knowledge. From the silver screen to the pages of your favorite sci-fi novels, infinity has a knack for popping up in some of our most beloved works of fiction. It's a concept that sparks imagination, offering a canvas for exploring the boundless possibilities of the human experience. Take the Marvel Cinematic Universe, for example. Those Infinity Stones that Thanos was so obsessed with, they represented fundamental aspects of the universe: space, time, reality, power, the mind, and the soul. The idea that someone could control these infinite aspects of existence is both terrifying and exhilarating, and it makes for one heck of a story. Then there's the mind-bending work of Jorge Luis Borges, the Argentine master of short stories. In his story, The Library of Babel, Borges imagines a library that contains every possible book that could ever be written. This infinite library, with its endless shelves and uncountable volumes, becomes a metaphor for the vastness of knowledge and the limitations of human understanding. And let's not forget the countless other examples: the Time Turner in Harry Potter, the Tesseract in Interstellar, the endless loops of Doctor Who. Infinity, it seems, is a wellspring of inspiration for storytellers looking to explore the boundaries of reality and imagination. Whether it's used as a plot device, a thematic element, or a way to inject a sense of awe and wonder, infinity has secured its place as a staple of science fiction and fantasy. So far, we've been dancing around the idea of infinity as if it's a single monolithic entity. But hold on to your hats, folks, because it turns out there are different flavors of infinity. One key distinction is between potential infinity and actual infinity. Think of potential infinity like the horizon. You can keep walking towards it, but it always seems to be the same distance away. You can count forever, always adding one more, but you'll never reach an actual end to the numbers. Actual infinity, on the other hand, is the idea that infinity exists as a completed totality, not just as an ongoing process. This is where Georg Cantor's work on set theory comes back into play. Cantor showed that there are different sizes of infinity, different levels of uncountability. He proved that the set of all real numbers is larger than the set of all natural numbers, even though both are infinite. This mind-blowing concept is just the tip of the iceberg when it comes to the strange and wonderful world of transfinite numbers. Cantor's work opened up a whole new branch of mathematics, exploring the hierarchy of infinities and their properties. It's enough to make your head spin, but it's also a testament to the boundless nature of mathematics itself. Welcome to the quantum realm, where things get even weirder than the concept of infinity itself. In the bizarre world of quantum mechanics, the study of the very small infinity pops up in some rather inconvenient places. For example, when physicists try to calculate certain properties of particles, like their mass or charge, their equations sometimes spit out infinity as an answer. These pesky infinities, known as ultraviolet divergences, have plagued physicists for decades. But fear not, for they've developed some clever tricks to deal with them. One such trick is called renormalization, a mathematical technique that essentially subtracts these infinities in a systematic way, allowing physicists to extract meaningful information from their equations. It's like balancing a wobbly table by strategically placing objects on top, making the whole thing stable, even though the individual parts might be a bit off kilter. Renormalization has been incredibly successful in making accurate predictions about the subatomic world. But some physicists see it as a bit of a band-aid solution, a sign that our current understanding of quantum mechanics is incomplete. The quest to find a more elegant and fundamental way to deal with these infinities continues, pushing the boundaries of theoretical physics and our understanding of the universe at its most fundamental level. Infinity pushes the boundaries of our understanding, representing both the vastness of the cosmos and the limits of human comprehension. From the tiniest particles to the largest cosmic structures, infinity weaves its way into the very fabric of reality. We've journeyed through mathematics, philosophy, physics, and even pop culture, exploring the many faces of infinity. We've seen how it challenges our assumptions, sparks our imaginations, and inspires us to ponder the biggest questions about our existence. Thanks for joining us on this journey through the infinite. Keep looking up, keep asking questions, and never stop exploring the wonders of the universe.